How's it going, everyone? Cup of Science Joe here. I had meant to record this one earlier, but I've just been super busy. I still wanted to get out here and make it, though. The topic for today is going to be the Luna 25 mission. Luna 25 launched on August 10th of this year, and it was slated to land on Monday, the 21st of August. Over the preceding weekend, Luna 25's engines were powered on to put the spacecraft into a pre-landing orbit. However, the engines had an issue with powering off and ended up burning for 127 seconds instead of the planned 84 seconds. These additional 43 seconds were enough to plunge the lander into the moon. The head of the agency laid blame for this on the country's 50-year-long pause in lunar exploration. That's longer than I've been around. This makes sense to me, though. Even in everyday life, our ability to perform a skill or task diminishes over time spent not using it. It is sad that the lander is lost, but I still want to talk a bit about what plans were in mind for this mission and a bit about the science instruments it had on board. The target of Luna 25 was the lunar South Pole. It had a main and a reserve landing site. Here, north of Boguslavsky crater, was the main site, and the reserve landing site was southwest of Manzini crater. The lander was equipped with a 1.6 meter long lunar robotic arm, or LRA. The purpose of this arm was to perform tasks such as removing and gathering surface regolith, and it could go to depths of 20 to 30 centimeters. It was equipped with a scoop and a sample acquisition tool. The mission was slated to run for around 1 year, and it was expected to study surface regolith and exospheric dust and particles during its operation. It was planning to do this using several science instruments. Let's have a look at some of the instruments that were on board the Luna 25 mission. We have Adron-LA, which is a gamma ray and neutron spectrometer. This would have been used for studying surface regolith. We have Ares-L. This could detect charged particles and neutrals in the polar exosphere. Speaking of the polar exosphere, we have another piece of equipment called the PML detector, which could study dust there. The LIS-TV-RPM is an infrared spectrometer that can measure surface water and hydroxide. This was mounted on the lunar robotic arm. LASMA-LR is a mass spectrometer which can measure the composition of regolith samples. STS-L is the panoramic and local imaging system. And Thermo-L could study thermal properties of the moon's regolith. My hope from this whole thing is that Roscosmos can learn from this mission and potentially come back in the future with a successful one. If you enjoyed this, please like and subscribe, and I implore you to step outside at night and look towards the stars.